Hello and welcome back to SAS From Scratch. Today's episode is episode 17. We're going to be looking at two topics that, to my knowledge, are not in the SAS-based prep guide, at least not the 5th edition that I have, but they are definitely on the exam. Now those two topics are transpose and then the very basics of macro variable assignment and referencing. Now macro variables and macros in general are a massive topic on their own. They are a big chunk of the SAS Advanced exam and the topics covered in the SAS Advanced exam. But for now, we're going to look at the absolute tip of the iceberg when it comes to the macro variables. That's the second item on today's agenda. The first thing that we're going to be looking at today is the PROC TRANSPOSE procedure. Now, if you're coming from R, you will be using probably the pivot wider and pivot longer procedures to transpose data. In SAS, this is called PROC TRANSPOSE, and it's a way of if you've never dealt with transposing data before, it's a way of turning your data 90 degrees to pivot something from, for example, apologies if you can hear my dog, to pivot something from, for example, a longer format to a wider format, or a wider format to a longer format. And the point of doing this is that it's sometimes easier to deal with something in a longer or wider format. What you want to be careful of is that you don't transpose over and over again. So if you are dealing with code and you find yourself transposing, doing something, and then transposing it back, the rule of thumb is that you could usually accomplish whatever you were doing by simply using a by group. So be careful of that. If you find yourself regularly transposing back and forth, you're doing something that can probably be solved by a by group. So be careful, because you're just going to cause yourself headaches. Let's look at the syntax for PROC transpose. So we've got, as with any other PROC, we've got a input data set that we pass. The output is at the top, similar to what you would see for a PROC sort. We've then got a couple of statements, and a bunch of these are optional, but you should really put them in because you don't want SAS to do its own thing. For the main reason that you want control over how the variables are named, which variables are going into the transpose procedure, etc. So we've already met our friend, the by group or the by statement. We know what that does. So that basically creates a grouping for the rest of the procedure. Now in this case, the by variables are the variables that are not being transposed. Excuse me. But they do provide a sort of grouping that the rest of the data is transposed within. So if you do something like you group by, say, a subject and maybe a treatment group, then you'll always have at least the one record per subject and treatment group, and then the rest of the data will be pivoted long. That's just one example. But the subject and treatment group in our example are not going to be transposed. So they will stay in the format that they are. Those columns are untouched. We can specify variables to be copied. So they are also untouched. They are not grouped by, but they will physically take a column and just copy it into the resulting dataset. And what that means is that if you had 1,000 rows in your source data set, then the normal expected behavior when you're doing a PROC transpose, if you go from, for example, a longer format to a wider format, is that you're going to end up with less records. Now, if you use the copy variable, you'll have the same number of records in the source and resulting data set. So you will have missings in certain cases where you've maybe not got data available. Use it carefully, play around with it. It's not something that I personally use very often, but the option is there. The ID statement points to the variable containing the names for the values you want to transpose. Now again, if we go back to the example of a lab values data set, let's say, for example, you've got something by subject and a certain treatment, and then you've got a column that has all of your lab tests. So you would have something like, well, what's the white blood cell count and the red blood cell count and the albumin, and all of those lab tests, they will have a name and a value associated with them. Now in the longer format, all of those names are contained in a single column. That'll be your ID column in this case. ID label will be whatever label is associated with that test name. So if you in the pharmaceutical sector, something like the SDTM LB for labs domain will have two columns. It'll have something called, for example, param CD. That is your short name. So for example, albumin will be abbreviated to ALB. And you'll have just param, which will contain the label, and it will actually there say albumin written out full length. And so in this case, ID is param CD, the shorter name, because that's the one without spaces or special characters, and that's the thing that we want to use when we refer to that variable in our code. ID label, on the other hand, allows us to point to that param column, which is the name written out. Maybe the unit is included in there in brackets as well. And that is a way of just decorating that column name with something more readable. So that's ID and ID label. If you don't specify the ID column, you'll get less descriptive column names. So SAS will go and name that something like col1 or col2 or whatever it might be. If you're using the ID label statement, that is also optional, so you can use ID without using ID label, but if you are using ID label, it must follow an ID statement. The var statement is the values you want to transpose. So let's go back to our example of the labs data set. We know that ID is going to point to param CD, the short name. ID label will point to param, that is the longer name, fully written out, the proper label for the parameter. And var is going to point to, for example, the column where the value is actually being stored. So in the case of the LB domain, that's going to be the LB stress n column, for example. And that's where that number actually sits, which says, look, I've got an albumin value of 32, whatever, U over L or whatever it might be. I can't remember what it's measured in off the top of my head. But either way, that's the value that's going to be transposed. And so if you've got your parameters listed long, so you've got albumin, white blood cell, red blood cell, any other chemistry or hematology or whatever you've got in there, if you've got that long, and in the next column you've got your values, so 30, 20, 15, whatever, then transposing that is going to bring that to a horizontal format. And you're going to have a column that says ALB for your albumin, and the values are going to be listed in there. You're going to have a column for RBC, your red blood cell count, and the values are going to be listed down. A column for white blood cell count, etc. So the whole thing is sort of tilted 90 degrees. But the first time, if you've never dealt with a transpose procedure before, it'll do your head in for the first couple of times until you start getting used to it and you get into the mentality of doing it. If you're coming from something like R, where you've used pivot wider and pivot longer, this is just going to make a lot more sense. The only thing to keep in mind is that SAS has a single procedure for doing this, and it's called PROC TRANSPOSE. If you don't specify, just the last item that I forgot to mention, if you don't specify a var statement, SAS will try and transpose everything numeric that is not mentioned in the by and the ID statements, and probably the copy statement as well. So any other numeric variables that are not mentioned in by and ID, it's going to try and transpose. It will not automatically transpose the character variables and it can do it because it just shifts it sort of a 90-degree twist. If you do want to do character variables as well to transpose them, you have to specify them in a var statement. They will not be done automatically like the numeric variables if you leave it out. I'm going to move on to an exercise for transpose because I think that's going to make things clearer. And I have a custom data set that I've created. It has a student, a bunch of student names, and for each student we're going to have a couple of assessments that they've done throughout their academic year. So we're going to look at some tests, 1, 2, and 3 tests that they wrote. We're going to have a semester project that they worked on, and we're going to have a final exam. And for each of these students, they'll have some of these assessments and they'll have scores for these assessments as well. What we're going to do is take this data set from its long format, so it's kind of going down, and we're going to put it into a wider format. Where each assessment is going to be in its own column or its own variable. The scores are going to be displayed in these columns, so they're no longer going to be in a single column. And we're going to play around with the ID and the ID label statements. That's what that third bullet point there is, where it says preserve the assessment names and labels as given. So we're not going to allow SAS to give its own names, so we have to specify an ID statement. And we want to assign labels as well, so we have to specify an ID label statement. Then lastly, we're going to take this wide format that we've created and we're going to shift it back to a longer format. And we're going to see what we can notice when we look at that, because there is going to be a small but important difference that happens. So let's get to that. I've got a file already created for us, so there's exercise 17.2 down there when we get to it, but we're going to stick with 17.1 for now. And just to give you an idea of what the data looks like, this is it. Sorry, I'm just getting my bearings. So this is the data that we're looking at, and we've got students. So you will see we've got 5 records here for Abe, we've got Bob, we've got Charlie, Dave, and Ed, and we've got these are all the records that we have. So we've got these 5 students, Abe, Bob, Charlie, Dave, and Ed, and they've got a short name for the assessment. So the system, for example, that this data comes out of. Now I've made this data up, but play along with this imaginary scenario. The system, for example, just calls it T1. So we've assigned a human-friendly label where we say, okay, this is actually the first quarter test. T2 is the second quarter test. T3 is the third quarter test. So this is probably some year-long course, runs for the full academic year. And they get a test every quarter. They get a semester project probably in their second semester. And then there's a final exam to be written as well. Now, we want these to be in a wider format, and we're going to do that with a PROC transpose. Now, the important thing just to keep in mind here is that the PROC transpose, in the syntax we saw there was a by statement. Now, we know that if there's a by statement, we should sort our data beforehand. And we're not going to do it here because this is already alphabetically sorted. But in practice, in real life, it's good to put that sort in there anyway to make sure that if your data changes at some point in the future, the sort is there to make sure that you don't, if you rerun this program 2 years down the line, that it doesn't give you some sort of error. And then you have to go looking for it and debugging it. So let's read our scores dataset in. I'm going to take it from the EP17 library, which we've mapped above, and I forgot my set statement. And if we read this in, we get exactly the same data as before. Let me move my face because you never know how these columns resize themselves, and then I might be in the way. So this is what our data looks like. Now, we've already said we're not going to do the sorting. We're going to go straight into the transpose, even though that is considered bad practice in general to do so. So we're going to set up a PROC transpose. We know what our input data is. It's this scores data set here, this one, which is in our work library. And I'm just going to call this output data set T. You would want to call it something more, you could call it scores underscore T, for example, to keep it short. I'm just going to call it T. What do we want to do? We know that if we look at this data, we want to keep the students grouped together. So we're going to be doing these transposes by student, because each student is unique and we want to group these tests and projects and exams by a particular student. So that's easy. We're just going to put in by student. And if we had different items we wanted to group by, for example, maybe there was a course as well, maybe there was a course codes. So we would have said, okay, well, this particular test and exam and whatnot belongs to a particular course code, so we want to group by student and course code. Now we don't have that complexity in this current example, so we can stick with simply grouping by student. If we look at our data again, this is going to be our ID column, because this is the machine readable one to some extent, because there's, well, SAS readable one, because there's no spaces, there's no special characters or anything in here. It's a nice short, in this case less than 8 characters. If we wanted to have it be XBT version 5 compliant, it has to be less than 32 characters otherwise. But this is a good name for a column, these values that we have here. And then our label is our human readable one. So we know that this assess label underscore label column will be our ID label column, and assess underscore name is going to be our ID column. So let's pop that in. So the name of the assessment goes into the ID statement, and we know that ID label must follow ID if we are using ID label. It's not compulsory. In this case, in the instruction, we were told to preserve the labels as they were given. And then finally, what data do we actually want to put into each of these columns? We want the scores to be in there. So our var statement is going to point to the score column. And it is as simple as that. We can run this and we get the following output. So this is the name of the label, the name of the variable that we transposed. If this variable called score had a label as well, you would have an underscore label underscore column created here for you automatically. Now in this case, this score column, let me run both so you can actually see what I'm talking about. So this score column here did not have a label. So this label and name are the same because it does not have a label specified. This dataset which has been transposed now takes test 163, puts it in this column, and so you can sort of do a cross check. So instead of having this long list, okay, Abe and finding test 1 or test 2 or test 3, you can simply do a cross check, so vertically, horizontally, and you can find a particular value. So for Charlie, for example, we can see test 3 is 62, and we get this cross created here. This also gives us a very easy way of noticing which tests or projects, for example, are missing from a particular student. So if we looked at this one, we could see that all the scores were present. There's not a single missing score in here. But by looking at the transpose dataset, we can see that, for example, Bob doesn't have a second semester test registered in the original data. And that's true. If we go and look at the source data, we see a quarter 1 and a quarter 3 test, but we don't see a quarter 2 test. And that's because it's not in here. So if we only looked at the score column, we would not have spotted that. If we look at the transpose data, that's very simple to see. Now, as I've mentioned at the start of this episode, what you don't want to be doing is constantly transposing back and forth, because that means you're doing something wrong. However, if we take this wider format and once again transpose it back to the longer format, then that's going to give us the missing values as well. So it'll give us a value for, it'll give us a record, a row for Bob for the second semester test. So we'll get that observation with a missing score, which we didn't have before. Let's do that in practice, because that's also the last instruction that I've put in here, to say let's transpose it back from wide to long, and what will we notice. Now I've kind of spoiled that surprise already, but you'll see that you get these extra records as well. So we're going to transpose T, which was the output data set here, and I'm going to give it the very imaginative name of T2. Again, please do as I say, not as I do. I don't always practice what I preach, especially in these examples. In the real world, where I write programs for a living and other people have to look at them and maintain them, I wouldn't do this. For the purposes of this example, I'm just doing something quick and dirty. So we're transposing T into a new data set called T2. We know that we still want to group everything by the student name. Our new name, however, is going to be this one, score. That's going to be our ID. And this was also the case in the original data set. All the scores were in a particular column. So we are going to group it under this score name. And where can that score name be found? In the underscore name underscore column. So our new ID is underscore name underscore. Which variables are we transposing? Which variables are we gathering back into this new score column? All of these variables, so T1, T2, T3, SP and FE, semester, project and final exam. We're going to specify all of these variables because we want to gather all of them under the one ID column. So we're going to say T1, T2, T3, semester, project and final exam. Now notice the difference that we're doing here. Here we had, if we look at the scores data set, we had numerous values under ID and we had one var. So that took it to a wider format. Now looking at our wider format, we have one name under the name column. So that's going to be our ID column. And we're gathering lots of vars under this one value, which means it's going to place it into a longer format. And if we run this, actually let me run all three, because that will, then we'll be able to see the differences quite clearly. I'm just gonna, I really don't like the fact that SAS doesn't always get the columns. There we go. Okay, so that width is better aligned. So this is where we started. Student, assessment name, assessment label, and score. We then transposed it into a wider format, and we got this output. We then said we were going to gather all these back up again and create a longer format, and we have this. So remember I said if there was a label on the columns, so if we go back to work.t, if you look at the values here, you'll see T1 still has its label of Q1 test, and it has that because we specified an ID label statement when we first did the first transpose. Same for semester project, final exam, etc. So now when we transpose those T1, T2, T3 variables back into a longer format, it knows that a label has to come along with it. And so we've got underscore name and underscore label. Now these correspond pretty much with assess name and assess label. We've just lost this information. So the only thing SAS knows about it is that it is a name and a label, but it can't see, you know, two transposes back what those original names were. We could have probably done something, you know, in the code. We could have put in a data option, and we could have done a quick rename, and it would have, we could have said, well, rename underscore name underscore to assess name, and rename underscore label underscore to assess label. We could have done something like that to get the exact same names back for these columns, but we didn't. So the way our data set looks now is pretty much the same, except the names of these two variables have changed. You will also notice that Bob does now have his Q2 test with the score missing. Charlie has a semester project with the score missing, and Ed has his Q1 test with the score missing. So we've gone from 22 records to 25 records because those missings were filled in by doing the double transpose. I hope that this is clear. As I've said, if you've never done a transpose before, it's going to take you some time to play around with it and wrap your head around it. If you're coming from something like R, where you've probably used pivot wider and pivot longer, this is not going to take you too long to wrap your head around. The important thing is just knowing when you're gathering multiple columns into one column and when you're spreading out multiple ID values for one particular var column. So that's kind of your, you know, am I going wider or am I going longer? Depends on that one to many, many to one, that kind of relationship that you're setting up. That's it for PROC transpose. I want to bring this up, but we're not going to look at that now. I'm just getting the spacing ready. The next topic that we're going to talk about today is going to be basic, very, very basic macro assignment and referencing. Now, the SAS macro language is a very, very deep rabbit hole in and of itself. It is a massive topic. The one thing that you need to know is that it is a way of altering the code of your SAS program. So you are changing the program code which goes to the interpreter before the interpreter actually reads it. And the way that is done is with the SAS macro language, which is a text pre-processing language. Now, other programming languages also have macro variables and languages and that sort of thing. I think C has it with the define keyword. And I believe that assembly has it, and maybe some of the older programming languages as well. I don't know of too many other programming languages that have this functionality, but SAS is, within SAS, this is something that it uses in a big way. Sometimes, in my opinion, also to the detriment of the programs, because people tend to want to sometimes do everything in a macro, or they want to use a macro as a substitute for a function. But a macro is not a function. A macro is just a way of copying and pasting text, of substituting text. That's all a macro does. And it is very useful, because if you can change the code of your program on the fly, that is something quite unique that not every other language has. The one thing to keep in mind is that a macro variable will always be a string or a character variable. Now, the reason why that is not a problem is because your text of your program is always characters. Your program itself is a string. So if you, for example, say that my day equals 3, that is a string. The number 3 might be a number, but the context of it in this program is a string. When the SAS interpreter gets around to interpreting your code, it's going to say, hold on, but this 3 is an integer. It's a numeric variable. But for the purposes of the code file itself, and if anything else reads that, it will always read that as text. And that's why for the macro language, or that text pre-processing language, that the fact that they are always strings or characters will not be a problem. The way that we do this, the way that we create macro variables, is with the %let keyword. So we are saying let my day equals 3, let my library equal this 1, 2, 3, 4, 5, 6 library here. And what we then do in the data step is we ask SAS to resolve this macro variable by putting an ampersand in front. So in the case of mylib, we recall the value stored in this token with ampersand mylib. Now, if there is ambiguity in the case of a dot, because if you only run mylib, ampersand mylib and dot, it will simply give you back this value. So we know that a library is a 2-level name. It has a library name dot a dataset name. Sorry, a dataset is always referred to by a 2-level name, and that is library dot dataset name. So in the case where there's ambiguity, you have to put a double dot to tell SAS to resolve this completely, and then add another dot. You can do the same here. So if, for example, for this day variable, you want to say day equals ampersand my day, and my day is mapped to 3, ampersand my day dot. You can do that in the SAS code. However, to my knowledge, this is not considered good practice, and the SAS exam, whatever the marking system, the backend, will mark it incorrectly if you redundantly add a dot where it is not needed. So if you do this in practice in your normal code, it will work fine, but the SAS exam software does not like it. So do not put a redundant dot if it is not necessary. The other thing that I want to point out here is what I said earlier about numeric. So what is happening here? We have that my day equals 3, and the macro language will simply substitute ampersand my day with 3. And so if you went and actually just typed day equals 3, that's all text, but SAS would have gone and interpreted that as the number 3. And that's why this is never a problem. If you did want the and we can take a look at that probably in the code as well. If you really wanted it to be a character, you could wrap it in double quotes. Let's take a look at the exercise that I've set up, and I will come back to the idea of a numeric variable. So for this exercise, and I've got the code in the SAS program file as well, we're going to start off creating 2 macro variables. The one's going to be called lib, the one's going to be called ds. Lib is going to accept the name of a library, ds is going to accept the name of a SAS dataset. Then we're going to do something very similar to what happened in this example here. We're just going to set up a data step, and it's going to read from &lib and &ds, which we've created here. Let's start with that. Afterwards, we'll introduce another variable which is going to restrict the number of records that we're reading in. So for now, let me get some space here. I don't like looking at all the previous stuff. We're going to create a macro variable called lib, which accepts the name of a SAS library. Let's do that. We know that we have to do that with the lib or the let statement. However, I do want to add some options here when we get to, I'll get to that later, to make our lives easier. Let's do let, and it can be uppercase or lowercase. SAS isn't case sensitive, so we can say let lib equals SAS help. We can say let ds equal cars, and you can already see where we're going with this. We're going to read in SAS help.cars, and I'm going to say data, let's call this macro test, run set lib dot, apologies, to recall it, it needs to be an ampersand, set lib dot ds. Now, why will this not work? Because lib is simply going to be resolved as SAS help. Lib dot will be resolved as SAS help. So I have to put an extra dot to tell SAS that it's SAS help dot cars. And if you do something like this as well, that should just resolve, this whole thing should just resolve to cars, but that is unnecessary and redundant, so we're not putting it in because we don't want to lose marks in the exam. If I run this whole section, we get work.macro test, which has read in the SAS help.cars dataset. Now, once you start working with the SAS advanced topics, there's a couple of options that make your life easier. I'm going to enable them here because they will just give us extra information in the log file. Now, I don't think we'll be using mprint and mlogic. I think it'll only be symbol gen. But once you really get into macro stuff, macro if statements and that sort of thing, these 3 options, having them turned on will make your life a lot easier. If we run this, you'll notice that it says in our log here, so see, we've enabled the symbol gen option, and it gives us extra information. It says symbol gen lib resolves to SAS help, ds resolves to cars, and that's what this is resolving to. So it's passing through lib.ds, but it says SAS help.cars. Now let's be very, very clear on what happened. The SAS macro language looked at this program before the SAS language interpreter looked at it. The SAS macro language changed, substituted lib with SAS help and ds with cars. And you have to have these ampersands in front, or the macro language parser will not know to go looking for these tokens in the symbol table. I'm using a lot of big words here that maybe you're not familiar with. As long as you can more or less keep track of what I'm trying to tell you, that's fine, because this is as deep as the macro rabbit hole goes for the SAS base exam. The absolute tip of the iceberg. Now, if we change this DS value, for example, to fish, and run this again, we get the sashelp.fish dataset within our work.macro test dataset. Why? Because lib resolves to sashelp, ds resolves to fish, and what did we read? Sashelp.fish. Now we had a second instruction to create a macro variable called reclimate, and we're going to set it to 5. You can set it to any number you like, and we're going to amend our existing data step by adding an obs option to it. Now we've done this before, I believe it was in maybe episode 5, 4 or 5, but I want to say 5. And that's a way of just saying read no more than 5 observations and then stop. So if there's 500 or 5,000 or a million, we're only going to read 5 and then we're going to stop. So we're going to call this reclimate, and we're going to map the value 5 to it. And we know that if we wanted to do this by default, it would look something like this. So we do set sashelp.cars obs equals 5. Now we know that lib is going to resolve to sashelp, ds is going to resolve to cars, and we just need this 5 to go to this reclimate. Although in this case we're pointing to fish, not cars. Apologies. Reclimate. Okay, so if we run this, we should get only the first 5 observations of the sashelp.fish dataset, which we do. Very important that we need to make sure we run these let statements along with the data. Now this is fine, this is not a problem, but if for example we add, let's call this reclimate 2, and we say, well, set this equal to reclimate 2. SAS is just going to say, sorry, I can't find reclimate 2. It's not resolved because you haven't placed it into the symbol table. And the way it goes into the symbol table is you have to actually run this and say, put this value into the symbol table so that it can be retrieved later. And now it works again. The one thing that I want to quickly look at is again that numeric stuff. So let's just say, let's just put any number in here. Let's say my num equals 3. So if I wanted to, I could go and say, let's put a new variable in here. Favorite number equals my num. If I wanted to say favorite character number, I would simply put that in double quotes. Why? Because this is equivalent to writing favorite number equals 3 and favorite number equals 3. Because the only thing SAS is going to come and do is substitute. And when the SAS non-macro language, when just the normal SAS language interpreter passes over it, it'll know in context whether you're giving it a numeric or a character value. So that's why it does not matter that this number is always seen by the macro parser as a character number. And we can test that. I didn't run it, did I? Again, you have to run it the very first time so that it gets placed in there. And so we can see from here, and I have again forgotten to move my face. We can see from here We have fav number, which is a numeric. It's a numeric type. And we have favorite character number, which is a character type. But they both came from the same macro variable. The SAS interpreter handles the context of whether it's numeric or character. The one thing just to keep in mind, for the most part, double and single quotes are completely interchangeable in SAS, but single quotes are verbatim. If something is in single quotes, the macro language will not attempt to substitute it. If something is in double quotes, the macro language will attempt to substitute it. So if we run this, we simply get verbatim what we typed in between the single quotes. If we put it back to double quotes, the SAS macro language parser will go and substitute the value for my num, and it will become quotes 3. That is basically it for the basics of the macro language. That is all you need to know for the purposes of the SAS base exam. And as long as you keep everything in mind I said about redundant dots and that sort of thing, you will be fine. Because it does not get much more advanced or involved than what we've done here today. Now, that is it. We have covered all of the topics, more or less. Excuse me. We have covered all of the topics, more or less, that we need for the SAS base exam. I think there's one or two things that I'll go over, but episode 18 will basically be me going over what you can expect from the SAS environment. It will be me going through the actual exam guide that the SAS Institute provides to say these are the topics you should focus on, and I will try and map those to the episodes that we've already worked on. The SAS environment is something we will talk about. There's more than one way to actually write the exam, but we've got to be careful with the setup and just make clear what the difference is between the two options for writing the exam. Other than that, we have made it this far. We've wrapped up all of the topics we wanted to cover, which is great. I hope that everything up to this point has made sense. If not, you're welcome to drop a comment down below and I'll see if I can, reply to that and clear things up. I would like to thank you for sticking with me through up to this point, 17 episodes of me waffling and rambling and, all about SAS. But I hope that it has been worthwhile. I hope that it has been useful. If it has been, feel free to drop a like as well. Always helps. And feel free to subscribe, because I am strongly considering also doing a series like this maybe on the SAS advanced topics. I'm considering doing a series like this maybe on the SAS for clinical trial certification, or whatever else pops into my head, because I have been having fun with the monologuing at the end of the day. That's it. Thank you as always very much for watching. I hope you have a great rest of your day. Cheers. Bye-bye.